Pre-calc, we meet again. So we are looking at this video after Friday's class. So that's the second. So sometime on Friday, Saturday, or Sunday. This class will be called the double angle ID. So we're going to develop from what we already know. We're going to develop the sine of 2a, the cosine of 2a, and the tangent of 2a. So before we can do that, we must revisit our trig Ids for sum and difference. So the sine of a sum, a plus b, sine a, cosine b, plus cosine A, sine B. How's your memory? Are you getting these down? Write them again tonight, just to help with memorizing them. A minus B is the same, sine of A minus B is the same as sine of A plus B, except for the sine, the SIGN, in between the terms. We go to cosine of a sum, whereas sine starts with sine, cosines of a sum starts with cosine. To be different from sine, it's going to be cosine A, cosine B. And when cosine is plus, the expressions contains a negative. And cosine of A minus B is the same as cosine of A plus B, except for the sign, the SIGN, in between is positive. Alright, so there are our trig Ids that will help us come up with a double angle. So a double angle is, I'm sure you are wondering, what is the sine of 2a? And if you continue on in math, you will use this. We used it in calculus today, so it just pops up here and there. So what is the sine of twice of angle? So I'm going to figure that out by looking at this trig ID. And as I write it again, can you try to envision what I'm going to do with it? What adjustment could I make to the sine of a sum so that it will give us the formula for the sine of twice an angle? Well, if I look right here, I could replace B with A. So then I have sine of 2a equals sine of a plus a. That is equal to 2a. So I can use the formula where my a is a and where my b is a. So in the formula, a will continue to be a, but we're going to also call the b part in the formula a. And so that would be sine a, cosine a, plus cosine A, sine A. So following the pattern, we have A plus A, and all the spots take on A. Can we simplify that? Sine of 2A, that's from here, equals this. We see this is sine A cosine A, plus cosine A sine A, so I can change the position of the expression, the factors in the last expression. That's commutative property for multiplication. And then I see I have like terms. So we have one of these and one of these. So when we have like terms, we can add them. So this plus this, 2 sine A cosine A. So it's like 1 apple plus 1 apple is 2 apple. 1 sine A cosine A plus 1 sine A cosine A is 2 sine A cosine A. So it's just adding like terms. How do you like them apples? All right. This is the formula that I used today in the middle of calculus class, and we were trying to take the derivative of something. When it was like that, it was difficult, but it was like that, it became much easier. So that substitution has some power behind it. Right, so that's our first one, and I said we would also find cosine of 2a. So let me just switch papers so we can kind of keep the trig IDs in sight. So let me get one without a lot of dots on it. Alright, so here's our trig IDs, and this time I'm going to develop cosine of 2a. And I'm going to remember that cosine of 2a can be cosine of a plus a. So that is the cosine of a sum. So that's this line. So I'm going to take the cosine of a plus a, and everywhere I find a b, I'm going to replace it with an a. Minus sine a sine a. So right here I took the cosine of a sum and I put in a for both variables. Come back into view there. Alright, so this says the cosine of 2a equals this expression, and I can't combine these, they're not like terms, but cosine a times cosine a is cosine squared a, and sine a times sine a is sine squared a. So that is the cosine of a double angle. And there is another form for this one. Sometimes it is helpful to use this expression in terms of sine only. So you'll recall from our Pythagorean IDs that cosine squared of a can be written as 1 minus sine squared of a. And so I'm going to make that substitution and simplify. So cosine of 2a equals 1 minus sine squared a minus another sine squared a. So that's 1 minus 2 sine squared a. So how's your algebra with trig expressions? All right, hopefully you see where that came from. How about cosine of 2a again? Is there another form? Well, up here we had it in a form that had cosine and sine in it. Here we had it in a form with only sine in it. So guess what's next? I'm going to take the original one up here and alter it so that it's only cosine in it. So I'm going to do that by replacing this with what? So behind that minus sign, I'm going to replace sine squared with what? From the Pythagorean ID, again, it's also sine squared is 1 minus cosine squared. Alright, so let's clean it up a little bit. Cosine squared a minus 1. This gets distributed to both terms. So we have a plus cosine squared a. Now we have cosine squared a and a cosine squared a added together. And a minus 1. So that is the third and last form for the cosine of 2a. All right, so those are the three for the cosine of 2a, and you have one is usually easier to use in the given situations that you'll find than the other. So write them all down. And lastly, we are going to find tangent of 2a. So I'm going to let that one, this is a you do, and I'll give you a push because the tangent of 2a is going to be the tangent of a plus a. So you're going to go off of that. And let me remind you, tangent of a plus b was tangent a plus tangent b over 1 minus tangent a times tangent b. So can you use the fact that the tangent of a sum is this to come up for a formula for the tangent of 2a, given that 2a is tangent of a sum a plus a. All right, so you're going to work on that and come up with the tangent of a plus a, tangent of 2a. All right, so when you get that, I will check it in the morning. All right, well, Monday morning. So impress me again with your deductive skills and have a great rest of your weekend. I'm ready to put in another full week of work. And not many left before we have a nice break, so let's give it our all. All right, I'll see you on Monday. Bye.